In this video, I'd like to look at solving graphs or solving equations by graphing them or graphing them. So here we've got an equation in the general form. Here we've got an equation as in the y equals mx plus c, or the gradient intercept or gradient slope, slope intercept, or however you want to say it. I'd say gradient intercept form. So because at the school at the moment we're going to be using gradient intercept, I'm just going to turn this into gradient intercept form. Although, to be straight up with you, using the general form here would be even simpler. But let's go ahead anyway and use gradient intercept. So the first one, or the second one, is in gradient intercept. So I'm just going to take the first one, and turn that into gradient intercept. So I've got y is equal to, x plus y. I'll write that right. Is equal to 5. So what I'm going to do is I'm going to subtract x from both sides. Here we are. So y is equal to, and I'm going to put the x first. So I've got a minus x plus 5. Of course, that means minus 1x. So 1 is the coefficient, 1 is the gradient. So I'll put m is equal to negative 1. And that's going to be important when we come to draw this thing. And y-intercept, I'll put equals 5. Now, we also really want to find the x-intercept here as well. And to find the x-intercept, so I'll put to find x-intercept, we make y equal to 0. So here it is. I'll do it over here. In fact, here we go. So y is equal to 0. Therefore, 0 is equal to, I've got minus x plus 5. So I'm going to add x to both sides. What happens when I do that? X becomes 5. So I've now got my x-intercept, and I've got my y-intercept. Here's my y-intercept, is 5. So I've got my x-intercept and my y-intercept are both 5. So here they are, x-intercept and y-intercept. Here we go. There they are. Now I could just, of course, just draw these up. Or I could start at one of those points and use rise over run. Because, of course, rise over run, if I make that rise over run, then this is really another way of saying negative 1 over 1. Because negative 1 over 1 is 1. So the run is 1 and the rise is negative 1. So I start at the leftmost point on the graph. Here it is. I go 1 along and 1 down. 1 along, 1 down, 1 along, 1 down. You can see we're going to end at 1 along, 1 down, 1 along, 1 down, and lo and behold, we go through these 2 points. So that's what I'm going to do. Now, I'm just going to grab a ruler. So here we go. Let's have a look. So here we go. So I'm going to make a point of putting arrows. Oops, you can't see that. Arrows on either end of the line, because it's not a line segment, it's a continuous line. There we go. All right, so excuse me. So I'm going to write the name of the line now. So it's going to be y is what's called x plus y equals 5. I'm going to rewrite it as y is negative x plus 5. So I'll write it on the end here. Y is equal to negative x plus 5. The reason I'm writing it there is I don't know where the other line is going to go, and I don't want to be writing stuff across the other line or across the equation label when the other line is being drawn. So the other line, though, is nice and simple. Let's do that now. So that was the first line. The second line is y is equal to 2x minus 1. So straight away I can go start at negative 1. So I'll put y-intercept equals negative 1. There we are. So there it is, y equals negative 1. There is y is equal to negative 1. But I'll write the coordinates. So it's going to be 0 along, comma, negative 1. There it is. This coordinate, by the way, I should probably write that in. That's going to be 0 along, comma, 5. This one, of course, is 5 along, comma, 0. 5, comma, 0. Best to write all the information in, yeah? Okay, now we want to find what the graph looks like, and I can see m is equal to 2, which is the same as saying 2 over 1, which we need to know because this becomes the rise and this becomes the run. So it goes 1 along, 2 up. start at the leftmost point that we know, 1 along, 2 up. 1 along, 2, oh, up. 1 along, 2 up. 1 along, 2 up. So you can see we've got quite a number of points here. I'm just going to draw straight through all of them. And you're not just drawing from point to point, you're actually going through all of the lines. Really important thing to do. So what you're showing again is the line, it doesn't stop here or start here. The line is continuous, it just goes on in both directions forever. So I put arrows at each end. There we go. Now we've got a point of intersection. You can see visually what that point is. In fact, it looks like it's going 1, 2, 2 along, comma, 1, 2, 3. Now, what we want to do is we want to confirm that that is in fact the point of intersection, and we're going to confirm it using simultaneous equations. So in this case, we can see it just by the graph, yeah? But I want to confirm it other than visually, so I'm going to take those two equations. Now, you don't have to do that for this question because it doesn't ask you to do it. But I'm going to do it because I think that this is a very useful thing to know how to do. So I've got x plus y is 5, and I've got y is equal to 2x minus 1. Now, at the moment, these are separate equations, but I'm going to make them part of the same equation, so I'm going to try and keep the equals under each other. So I'm going to rewrite this by subtracting x from both sides. So now y is equal to negative x plus 5. Now, because y is equal to this and y is equal to that, y must be equal to y. And this thing here must be equal to this thing here. So I can just rewrite that. I'm going to say 2x minus 1 is equal to negative x plus 5. Now I want to get all, I want to get all the x's, all the unknowns to the left side, and all the knowns, they're things I know, to the right side. So I do know this negative 1, so I'm going to add it to both sides. There it is. Of course, I'm now left with 2x is equal to, and I've got a negative x, I've got a plus 5 plus 1 is plus 6. I could add x to both sides. I'm going to add x to both sides. And then 2x and 1x is 3x is equal to 6. Now 3x is 6, I can divide both sides by 3. And x now becomes, well, 3 goes into 6 twice. So x is equal to 2, that's my first value. Now I'm going to take that x is 2 and plonk it into either of the other equations. Does not matter what I do. I'm going to just take the first one. Y is 2x minus 1. So y is 2x minus 1. And I'm going to substitute that 2 straight into the equation there. So y is equal to 2 times 2. There it is. There's my 2 minus 1. Well, 2 times 2 is 4. Minus 1 is 3. So y is equal to 3. Now I can express this as an ordered pair. Therefore, I put point of intersection equals, and I'll put 2, comma, space 3. So I'm writing it as an ordered pair. Now let's check that that is in actual fact correct. Is that what we got when we had our diagram? Yes, it is. Look, there it is, 2, comma, 3. So that is how we would find the point of intersection.